Hey everybody, I wanted to go over the 1.1 lesson with you guys again real quick, as quick as possible, just so that way you guys have a better grasp of what's really expected of you and how to work with all these different equations of lines. So whenever I'm going through and marking up my notes, whether I have them digital copy or a pen and paper copy, I still like to do the same kind of things, highlight, annotate, and things like that. So if you've got paper, you can just even consider like what I'm writing down. These are the things that you should be adding to your notes, or even just write them on a separate sheet of paper for now and save them. Save them as a companion to your 1.1 notes. Keep them in a physical binder. I don't care. All right, so first of all, the biggest thing about a line is the gradient, right? The gradient M measures the steepness, and I want to think about writing a few other things over here just to remember the most important things, formulas I like to rewrite if need be. So it's rise over run, y2 minus y1 over x2 minus x1. And IB calls that gradient, but it's really the same thing as the slope. Okay? Now, we see that there are three different ways that we can write an equation of a line, and that is gradient intercept form, which is y equals mx plus c, where we have m is the gradient and y-intercept c. I don't need to focus on that too much because I remember that from Algebra 1. Okay? Then we have point gradient form. Point gradient form is a little bit different, but what it is you need to focus on the y1 and the x1, and that's going to be given to you by a point. You also do need m. Okay? So again, point gradient form. I'm going to write that stuff down over here because this one maybe is a little bit new to me, or I don't remember too much about it. Y minus y1 equals m times x minus x1. Okay? I want to remember that formula, so I'm going to utilize it. And then there's this other one, general form. Now, I've seen these in algebra classes before, but I always got kind of frustrated with it, and I didn't really see the point of it, but it is on a lot of IB examinations. So there's general form. I'm going to write that down too. That's ax plus by equals d. And so now we're going to learn how to graph them based off of these. Lines in gradient intercept form. I remember how to do that, right? C is the y-intercept, so I plot that point on the y-axis, and then I do my rise over run to get to that point. I don't need to address that. But general form, how am I supposed to graph stuff with general form? Why is this even useful? Okay, here it is. Find the y-intercept by setting x equal to 0. Find the x-intercept by setting y equal to 0. Okay, and I want to rewrite that in a way that makes sense to me. Okay, so I'm going to use that over here, and I'll rewrite that. What this tells me is that general form gives the x-intercept if I plug in 0 for y and vice versa. I'm just rewriting what's already there. This is how I can add my understanding to the notes. So general form gives the x-intercept when you plug 0 in for y and vice versa. And I know that if I have the x-intercept and the y-intercept, that gives me 2 points on a graph, and I can then connect those 2 points and make myself a line. So there, okay, general form isn't so bad. That seems to kind of make sense. All right, let's move on to the next page. Parallel and perpendicular lines. Okay, parallel and perpendicular lines, I remember what these are, but I'm going to highlight just to make sure there's anything else. Parallel lines have the same gradient. Okay? Perpendicular lines have gradients that are opposite reciprocals to each other. And this is actually a really common thing that we need to address whenever we're looking at IB exams. We love to look at bisectors. So, to make not bisectors, but perpendiculars. To find a perpendicular, you really need to just focus on one of the slopes, right? So, the way we find the perpendicular slope, the opposite reciprocal means flip the fraction upside down. Numerator goes to denominator, denominator to numerator. Also, the fact that it's the opposite, it just means change the sign. Okay? Flip fraction, change the sign. This gives the gradient. This gives a perpendicular gradient. Okay? There we go. I'm adding meaning to my notes. All right. Next, Vertical and horizontal lines. Oh, this is actually good because I know some of this stuff, but I don't remember everything. So I see this line y equals 2. Notice, where does it cross? It crosses at the y axis at 2. So a horizontal line is always going to be written in this form, y equals c, where c is the y-intercept. What about vertical lines? Vertical lines I always had trouble with. Okay, vertical lines, I see that this says x equals 3. Okay, so where does that show me? Well, where does it cross the x-axis? So vertical line actually gives me the x-intercept. So we'll say vertical lines can be written out like this, x equals k, where k is just going to be some number. But what's special about that number? I'm going to define it, where k is the x-intercept. Okay, and there we go. So vertical lines have an undefined gradient. They go straight up and down, but you write them as x equals some number, whereas horizontal lines, we write them as y equals some number. Okay, next. This is where things can start to get a little bit gross, is by trying to figure out how to work through an example. Okay, and we have to kind of go back and forth a bunch with all of these different examples until we really get solid with it. All right, so write the equation of a line in all three forms if we know it passes through these 2 points. So we know 2 points. Well, if we know 2 points, that means we know we can find the gradient. Okay, so we need gradient and a point at least in order to find a line. That means I've got at least a point. Now I just need to find the gradient, and look at that. That's step number 1. Okay, so step 1 is to find the gradient. Do I have an example that kind of goes along with this? You bet I do. So I'm going to kind of go by step with each of these and try and do it on my own. Okay, so I've got 2 points, and I want to write the equation of the line that passes through these 2 points. Okay, and I want to do it in all 3 forms. So my first step is to find the gradient. Well, I know how to find the gradient. M is going to equal y2 minus y1, so that's 5 minus 2, over 4 minus 7. When I reduce, or I simplify, that's going to be 3 over negative 3, and that simplifies to negative 1. So boom, I've got my gradient. What's step 2? Step 2 says, using any point, A or B, substitute the gradient and the coordinates of your point into point gradient form for a linear equation. Okay? So I'm going to use this one, and I need to remember what is point gradient form. So I'm going to have to scroll back up to the top because I don't remember point gradient form off the top of my head. And scrolling through, there it is. Y minus y1 equals m times x minus x1. I'm going to write that off to the side. Again, the more times I write it, the more comfortable I will be with it. So this is my point gradient form. Okay? And this makes sense because now I have a gradient and I have a point. That's 2 things that I need. So the point I'm going to use is this one, A, and that's going to plug in y minus 2 equals negative 1 for my gradient times x minus 7. Okay? Now, this isn't quite point gradient form yet because we haven't simplified everything. So let's take a look at what is step 3. Step 3, oh, look at that. It does say simplify. Okay, perfect. That's exactly what we want. Simplify. This is point gradient form. So, simplifying. We have y minus 2. Those are not like terms, so we can't combine them. I can distribute the negative 1 to each term, though, and that turns into negative x plus 7. Now we have point gradient form. Perfect. Okay. Next thing that we want to try and do, so here's my point gradient form. Okay. When I look at this, what is step number 4? I don't remember what step number 4 is, but I can kind of guess. If I need to write equations of all 3 forms, maybe I want to go into either gradient intercept, or maybe I want to go into general form. What does this say? Step 4 says simplify. This is gradient intercept form. Okay, simplify. Let's try and then gradient intercept form, I know everything goes to one side. So we have y equals negative x plus 9. Notice all I did there was add 2 to both sides. Okay? So this is my gradient intercept form. What's the last one that I need? General form. Here's my example. Rewrite this in general form. Okay, general form. What's general form? I don't remember. Let me go up to the top. Let's see, what's general form? General form, oh, that's right. All my variables are on one side. Maybe I want to add a note to that. All variables on one side. Also, to note that's special about this, all coefficients are integers, meaning no fractions. Okay, if we have fractions, we're going to have to fix them. All right, so let's go ahead and get everything to one side and make sure we don't have any fractions. So this is really easy. All we have to do is move this negative x guy over here. We need to move that to the left side. We do that by adding, and that's adding x to both sides. Leaves us with this, and this is now general form. I'm going to highlight each one of my answers because I want to make sure, did I get all three of my forms? And actually, this one here in step 2, this is going to be this is really point gradient form because notice how we have the slope outside the parentheses? That's point gradient form. All right. So, next thing is to look at another example. So example 3 is saying find the equation of a perpendicular line to x plus 2y equals 6 that passes through -2, -1. Okay, so we've got 4 steps, rewrite in gradient intercept form to find the gradient. Okay, so I'm going to maybe rewrite these steps that I can make it work for me. So first, find gradient. Okay, step number 2. Flip the slope. So for the perpendicular. Step 3 says to use the gradient m2 and the given point -2, -1 to substitute into point gradient form. Okay, well, that means I want to plug in my new slope and point into point gradient form. And then step 4 says rewrite in gradient intercept form or general form. All right, so that may not even be required. I'm just going to say rewrite if needed. Now I've rewritten these instructions in ways that might be more helpful for me. Okay, let's go ahead and take a look at this next one. This one's slightly different. Okay, now we got to pay attention. Find the equation of a parallel line to 3x minus y equals 2. But it's going to kind of be the same idea, except here we're just not going to do step number 2. Step number 2 is going to be out. Okay? All right, so let's go ahead and undo that guy right there. We don't need him. Now, 3x minus y equals 2, and it passes through the point 1, 4. First step is to find the gradient. So I'm going to try and write it in gradient intercept form like it suggests. Let's move the y to the other side just by adding y. And then subtracting 2 to both sides, okay? You can do all this algebra in a couple of easy steps. So we have 3x minus 2 equals y, and then I can see very clearly that 3 is going to be my gradient. So m equals 3, and now if we look at the second line, m2, so this is m1 of our original line, m2, since it's parallel, they have the same gradient, 3. So we've got that. We took out step number 2. Now we need to plug in our new slope, which is 3, and we need to choose our point. We have our point, 1, 4, and we're going to plug that into point gradient form. So y minus y1 equals m times x minus x1, and my point is y minus 4 that I'm plugging in. 3 is my slope. X minus 1 is the x-coordinate of my point. Okay. Well, look at that. That's in point gradient form. That's great. That's really, since this problem doesn't say anything else, that's kind of sufficient. But if we want to be a little bit extra, who doesn't want to be extra? Let's go ahead and be extra, and let's find it in gradient intercept form because it's easy. Y minus 4 equals 3x minus 3. I'm just distributing the 3 into each term in that parentheses, and now I'm going to add the 4 to both sides. So that gives me y equals 3x plus 1. So that's in gradient intercept form, okay? And now let's talk about general form. General form is also going to be pretty easy. Remember, we just want to get the variables all on one side. So now I have y minus 3x equals 1 by subtracting the 3x to both sides. And boom, done. Super easy, okay? Don't overcomplicate things. Let's just get it in, get out, and get this stuff done. Algebra is your friend, not your enemy. Make it work for you, not the other way around. Okay. Next, graphing. Okay, so graphing, I know how to graph. That shouldn't be all that tough. Let's go and take a look and see what are we suggesting here. So we got two different graphs. Y equals negative 1/2 x plus 2, and then there's also 2x minus 4y equals 12. We say, okay, how are we supposed to do each one of these? Well, first of all, let's think about what are each of these graphs. This one, what form is that in? That is in gradient intercept form. I know how to do that, right? All we do is just plot that point and then make our steps by the slope. So that's easy. I don't need to focus on that one. Okay? But let's look at this one, general form. So maybe I don't need to worry about that one for right now, but let's focus on this guy right here. Okay? When x equals 0, we have negative 4y equals 12. Therefore, that's what these three dots mean. These three dots mean therefore. Y equals negative 3. So the y-intercept is negative 3. Okay, I understand what we're saying here. But what we're saying is this is general form. That's right. And if this is general form, then that means I can just find the x-intercept and the y-intercept, and then I can plot those 2 points. And I remember how to do that, right? I wrote in my notes up at the top here how I'm supposed to do that. General form gives you the x-intercept when you plug 0 in for y and vice versa. So that means if I plug in 0 in for x, it'll give me the y-intercept. That's perfect. Let's go ahead and do that in our example. Okay, so I'm actually going to start with B part first, right? Because that one's in general form and I can see that. So let's go ahead and work with part B. First step is to plug in 0 for x. So we have 0 plus 3y equals 6. I'll divide both sides by 3. So that way I can get my y coordinate 2. And what does that tell me? 0, 2 is going to be one of my points. Okay? Because again, we plug in x equals 0. That gives us the y-intercept. Now let's plug in 0 in for y to find the x-intercept. Well, that one's super easy. X equals 6. So that gives me this point, 6, 0. Look at that, 2 points. That took me all of about 40 seconds, maybe. And I can graph those points very easily. Okay? So I have 0, 2, and 6, 0. 1, 2, 3, 4, 5, 6. 1, 2 on the y-axis. Here's my point, 0, 2. Here's my point, 6, 0. Draw them with a straight line, as straight as you can. Boom, done. Look at that. That was probably easier than even slope-intercept form. Okay, let's try slope-intercept form. Let's try the other one. I'll use a different color this time. We'll use the green. So here, we are going to start off with y equals 3 over 4, x minus 1, and we have 3 over 4. Okay, so that's my slope. And then we have also negative 1. Okay, that's going to be my y-intercept. That's c. So I can plot this by first of all plotting negative 1 down here on the x-axis, on the y-axis. That's my y-intercept. And now this tells me 3 over 4 means I need to rise 3. So that's up 3. And then I need to run 4. Since both of these are positive, that means we are going up and to the right. So 1, 2, 3. And then over running 4. 1, 2, 3, 4. So I go up 3 and over 4. There's my next point. Connect them with a straight line. And that's it. Okay. So your challenge for each of these problems that you've got on your homework is to try and just rearrange, work within each one of these different forms and see which one benefits you the most. In this case, don't rearrange that. We don't need to. We know what form that's in. That's in gradient intercept form. Go ahead and graph it with something like this. Okay, that's general form. Could you rewrite it into gradient intercept? Sure. That works for you, go for it. But try and use these notes as a guide to to help you understand what is the quickest way to get through each one of these problems. All right, you guys, thanks very much for watching. Hopefully this is helpful, and I will see you on Wednesday. Come ready with questions. Have a wonderful day.